Alright, video R5. This is the third one. Sorry these are taking so long. Sometimes these lessons just get to be so long. And let's look at example 5b. Okay, so there's B. The two numerators can't be simplified, so we're just going to worry about the bottom. So what we're going to do is we're going to simplify the bottom. And the first bottom does this. And the second one gives me, let's see, x squared plus 9x plus 20, x plus 5, and x plus 4. Those two added give me the 9, multiplied give me my 20. Okay, so now I'm looking for common denominators here. So what do I have, what am I missing here that I have over here? X plus 5, x plus 5. I'm missing an x plus 4. So I'm going to multiply this bottom and top by x plus 4. Alright, let's see, am I missing anything here? I've got an x plus 5, x plus 5, x plus 4, x plus... Okay, missing an x plus 6. So I'm not missing an x, I'm not missing a 6, I'm missing the quantity x plus 6. So now what do I have here? If I multiply that out, I get x squared plus 4x. And I've got a common denominator now, so I can just put the whole thing over x plus 5, x plus 4, and x plus 6. Alright, so I'm going to rewrite that as 5x plus 30. Okay. Let me remind you what we did here. This minus here is on both of these. It's on the 5 times x plus 6. So this negative here, once I put them all over the same denominator, this negative, it changed the 5 to a negative, but the negative also changed the 30 to a negative. So I'm going to have to, let's make that go away, and make it minus 30. Okay, so again, when we took this negative is on this entire thing. So basically it's like negative 5 times x plus 6, which gives me negative 5x plus 30. So this negative, when I take the parentheses off, distributes to both numbers there. Okay, so just showing you what was going on there about how that changed signs. That is so important in this level of math, is knowing what to do with that stinking negative sign. Okay, so once we get there, we keep going here and we end up with x squared minus x minus 30. So we combine terms there over this denominator. I'm not going to write all that out. Well, maybe I should, because we're still not done, because I've got that numerator there that I'm going to want to see if I can reduce that at all. Let's see, x squared, I've got a 6 and a 5, give me a 30, and a difference being 1, that would be right there, so that probably is going to work. X plus 5 and x minus 6, make that a negative, because this is a negative, the biggest one has to be. X plus 5, x plus 4, x plus 6. So let's see what we've got here. That cancels with that, and then this is what we have left for an answer. Okay? So hopefully you're starting to feel like, okay, I'm kind of getting this, but it's practicing that doggone negative stuff. You know, what do you do with the parentheses and the negatives, and how do you make all that happen so you don't get your negatives messed up? You know, all I can say is you just have to be really careful and really conscientious about what we're doing. All right, let's go to complex rational expressions. The only thing a complex rational expression is it's basically a fraction over a fraction. So a complex fraction would be like 1/2 over 2/3. You know, it's just a little bit more complicated. Ergo the word complex. All right, so there's two methods to do this. First method is to find the least common denominator of all the denominators. And the second method is first add or subtract to get a single rational expression. All right, so what we're going to do is I'm just going to look at the way I do this. In fact, I use method 1, finding the least common denominator, because you're not learning new material. You're not trying to remember. So what do I do here? You do the same thing you always have done. So hopefully that'll make it a little bit easier. So let's look at example 6. And one of the reasons it's complex too is because all we have are variables except for cubes there. So I'm going to turn this off and write the problem down, and then we'll continue. Okay, so there's example 6. And what I teach students is we do everything in the numerator first, and then we do everything in the denominator. Okay, so we've said that over and over and over again. Simplify the numerator, then simplify the denominator, and then if you can cross the division line here, cross and do what you can. Sometimes you can, sometimes you can't. All right, so what does that mean? I'm adding two fractions. And what did we just go over about adding fractions? You have to find common denominators. So I look and say, all right, I've got an A there. What am I missing? Well, this one has a B. So I'm going to multiply top and bottom here by a B. And what am I missing here? I'm missing an A. So top and bottom by an A. So what do I have? I have B over AB plus A over AB, which leaves me with that. And actually, if I want to put it over a common denominator, I can just write it this way. Okay? A plus B all over AB. All right, so that's my numerator simplified. Now let's look at the bottom. What am I missing? Well, I'm missing a B cubed over here, and I'm missing an A cubed over here. So again, we're just looking at the denominator, so let's draw a line here so that we're not getting confused. Put a all right, so I end up with B cubed over A cubed B cubed plus A cubed over A cubed B cubed, and put them all over one denominator, A cubed plus B cubed over A cubed B cubed. All right, so right there is my simplification of my initial problem. So next step, see, notice that this is this fraction divided by this one. So I'm going to take this and turn this one upside down and multiply it. So I'm inverting and multiplying. Again, if you want to know why inverting and multiplying works, find me and I can explain it to you. I'd be happy to do that, but most of the time you just are interested in how to, not the why to's. Alright, so that gives me that. Alright, so what in the world am I going to do with this? Well, here is the sum of two cubes. So back in one of your other lessons, when you had something cubed plus another one cubed, there was a formula there. So let's go ahead and rewrite everything as is, but change that A cubed plus B cubed. So A cubed, B cubed. So instead of writing it as A cubed plus B cubed, we're going to write it as A plus B times the quantity. What was it? A squared minus AB plus B squared, if I remember my formula right. Alright, so let's see. Can we cancel anything? Yes, I can cancel that with that. I can cancel one of my A's there with that one, and one of my B's there with that one. So what does that leave me with? A squared, B squared, because those went away. So all I have is what was left there, all over A squared minus AB plus B squared. Okay, so the book did it a hair different than I did. they ended up with b squared minus ab plus a squared. So they just switched their a squared and their b squared around. Doesn't matter because they're both pluses. I just always like my a before b, so that's why it's a little bit different than the book is, but the answer is the same. Alright, so that is it for R.5. And gosh, I've gone over so many of these with you, and this video is getting to be so long that I'm just going to stop there. And if you have questions over any of the homework, just let me know.